So when substitution is not possible, because there are restrictions on the function we're trying to take the limit of, we can try and rewrite the function to make it possible to evaluate, because up until now we have used substitution to evaluate a limit, because all of the functions we have analyzed are known to be continuous. However, there are limits where substitution cannot be evaluated without rewriting it. So the two main approaches we can take to evaluating limits algebraically are through factoring and multiplying by the conjugate. So first we're just going to talk about factoring, which will be in green. So our first example of evaluating limits algebraically by factoring is this. So here we have a function where we're taking the limit of the function as x approaches 5. But since we know that here is a difference of squares and it will factor out into x minus 5 and x plus 5, we know that if we plug in 5 for here, then it'll be 5 minus 5, which is 0, so it'll all be over 0, so we can't take the limit of that. But if we also factor out the top, it becomes x minus 5 times 2x plus 1. Now we have something we can cross out. So we can see that as we take the limit of x approaching 5, we can cross out these two, leaving us with 2x plus 1 and x plus 5. Now, using the quotient rule that we learned previously, we can try and take the limit of this, because if we plug in 5 to here, then it'll give us 10, and so we will be able to take the limit. So we can use the common multiple law, sum law, and quotient law while doing this. So this becomes the limit of 2x plus 1 over, as x approaches 5, all over the limit of x plus 5 as x approaches 5. And then using constant multiple law and the sum law, we can rewrite this as 2 times the limit of x plus the limit of 1 as x approaches 5 on both, all over the limit of x as x approaches 5 plus the limit of 5 as x approaches 5. When plugging in numbers, this gives us 2 times 5 plus 1 over 5 plus 5 plus 5. So this gives us 11 over 10. Another example down here, so we have the limit as h approaches 0 of 3 plus h all cubed minus 27 all over h. So once again, if we directly plug h into the limit, we will get it over 0, so we can't take the limit of that. So we have to try and factor it out so that the h crosses out somehow. So we know that we can expand this out. So let's start off by expanding 3 plus h cubed. So it expands into 27 plus 27h plus 9h squared plus h cubed, and then we add this negative 27. These two will cross out, and that'll all be over h. Now we have a common factor of h in these three terms, so we can factor out the h. So h times 27 plus 9h plus h squared over h, those can cross out, and now we can just take the limit of these three terms. So it becomes the limit as h approaches 0 of 27 plus 9 times the limit of h as h approaches 0 plus the limit of h squared as h approaches 0. So plugging in h here, it'll be 9 times 0, 0 squared. So the limit of 27 is 27, so the final answer will be 27. And one last example is the limit as x is approaching 2 for x cubed minus 8 over x minus 2. So x cubed minus 8 is a difference of cubes, so we can expand that into the limit of x as x is approaching 2 of x minus 2 times x squared plus 2x plus 4 over the limit of x approaching 2 of x minus 2. And this crosses out. So then we are left with the limit as x approaches 2 of x squared plus 2x plus 4 And we can simplify that using constant multiple and sum laws to become the limit as x approaches 2 of x squared plus 2 times the limit of x as x approaches 2 plus the limit of 4 as x approaches 2. Plugging numbers in, this gives us 4 plus 2 times 2 plus 4, which is 4 plus 4 plus 4, which equals 12. So those are 3 examples of evaluating limits algebraically using factoring, but there is also another way of evaluating limits algebraically, which is multiplying by the conjugate. So the conjugate is most often used when a function has a root in either the denominator or the numerator. So by multiplying the function by the conjugate of the numerator or denominator on both top and bottom of the function, we can usually find the limit of the function because it cancels one of the roots out. So for example, in this question, it asks for the limit of x approaching 4 for 1 over root x minus 2 minus 4 over x minus 4. So if we plug in 4, we can see that this would be 1 over 0 minus 4 over 0, which doesn't work out. We can't take the limit of that. So to get rid of the root on the bottom, well, first of all, we can make this to be related to the denominator on the left side, because if we take the root of this function, it becomes the limit of x approaches 4 of 1 over root x minus 2 minus 4 over root x minus 2 times root x plus 2, because that is technically a difference of squares if you make it root x. So then now we have that. We want to make this, well, this isn't really multiplying by the conjugate, but it kind of like it involves it in a way, so you can see how it can cross out some certain things. So if you want to add these 2 parts together, but so we want to put it all over a common denominator, so we have to multiply this part by x plus 2. So it becomes the limit of as x approaches 4 of x root x plus 2 over root x minus 2 times root x plus 2 minus 4. So that becomes then the limit as x approaches 4 of root x 2 minus 4 equals negative 2 over root x minus 2 times root x plus 2. So these 2 can then cross out, so then we're just taking the limit as x approaches 4 of 1 over root x plus 2. And if we plug that in, that's the limit of 1 as x approaches 4 divided by the limit of root x as x approaches 4 plus the limit of 2 as x approaches 4, which equals 1 over root 4 is 2 plus 2 equals 1 over 4. So here, there's nothing like it was in the beginning. So it's, for this example, this is solely multiplying by the conjugate. The top one you can kind of figure out using what we've learned in pre-calc about adding fractions to make, because you have to make the denominator the same to add them, but for this it's strictly using the conjugate. So first of all, we have to multiply both things by the conjugate of the thing that has the root. So we want to multiply this by root x minus 4 plus 2. That's the conjugate of root x minus 4 minus 2. And we have to multiply both top and bottom. You have to remember that, because if you just multiply the top, you can't do that. Whatever you do to the top, you must do to the bottom as well. So after we distribute this out, this becomes the limit as x approaches 8 of x minus 4 over x minus 8 times x minus 4 plus 2. There's no reason for us to distribute the denominator out, because as we combine this part together, it becomes the limit as x approaches 8 of x minus 8 over x minus 8 times the root of x minus 4 plus 2. So then these two things cross out because at the beginning we want to cross out the 8. We want to find out a way we can cross out the 8 because the 8 is our restriction. If we plug it in, then there's a 0 in the denominator. So that's why we don't want to distribute the bottom out. So once we do this, we can just use limit laws and plug in. So it becomes the limit of 1 as x approaches 8 over the limit of x minus 4 minus the limit of 4 as x approaches 8 plus the limit of 2 as x approaches 8. And then by plugging in numbers, this gives us 1 over the root of 8 minus 4 plus 2 equals 1 over root of 4 is 2 plus 2 equals 1 over 4. And for our last example, this one's a little bit harder because you have two parts, both numerator and denominator have a root in the function. And we once again want to get rid of the root on the bottom because when we plug in x equals 4 on the bottom, it gives us 0. So through trial and error, you can multiply it by both the conjugate of the top and of the bottom if the top doesn't work when you first use it. But usually if one works, then that means that that is the answer. But if neither multiplying by the conjugate of top nor multiplying by the conjugate of the bottom works, then that means the limit does not exist. But in this case, when we multiply the function by the conjugate of the top, which is root 5 minus x plus 1, and we have to multiply that to the bottom as well, then that actually does cancel out. So this becomes the limit as x approaches 4 of 5 minus x minus 1 over 2 minus root x times root 5 minus x plus 1. And here, this numerator can simplify into 4 minus x over 2 minus root x times root 5 minus x plus 1. And there is a relationship between 4 minus x and 2 minus root x, just like in the very first example that we did. This is technically a difference of squares, so we can rewrite that as the limit as x approaches 4 of 2 minus root x times 2 plus root x over 2 minus root x times root 5 minus x plus 1. So then now we can cancel this out, which gets rid of our restriction. So then we can plug in for x. So this becomes the limit of 2 as x approaches 4 plus the limit of root x as x approaches 4 all over the limit of 5 as x approaches 4 minus the limit of x as x approaches 4 plus the limit of 1 as x approaches 4. So plugging in the numbers, then this becomes 2 plus root 4 is 2 over the square root of 5 minus 4 plus 1, which is 4 over the square root of 1 is 1 plus 1 is 2. So this final answer is 2. So just to summarize once again what this entire video was, when we are evaluating limits algebraically that have restrictions on the bottom because we are plugging in an x value that will create a 0 on the bottom of the fraction, we can either try and factor the function or to multiply by the conjugate so that the bottom number does not equal 0.